Hi guys, this video we will learn about how to do basic inverse Laplace transform. Alright, and in order to do this, we will have to refer to the Laplace table. So for the subsequent examples, not just for this video but also for the next videos, we will keep on referring to the Laplace transform table, and we do not have to use Laplace integrals. We can just refer to the table directly. Okay, now, so basically, um, inverse Laplace transform is the reverse process of the Laplace transform. Now, let me just recap back what you have learned before in the previous module. So, Laplace transform is basically a process which transforms a signal in a time domain into a signal in the spatial domain. Therefore, the inverse of Laplace transform, okay, we take a signal in the spatial domain, okay, and we inverse it back. It is a process that reverse back the Laplace transform, and we will get the original signal in the time domain. All right, and in order to write this into a formula, so basically, if you are being given Laplace of ft is equivalent to fs, so you can only imagine that the inverse, which is denoted by L negative 1, yeah, of fs, you will get back the original signal of ft. Now let me just demonstrate this with one example. All right, assuming you are being given a signal fs, which is 0.2 s plus 1.4 over s square plus 1.96, and the question is basically asking you what is ft. Okay, so clearly this is a process for inverse Laplace transform. Now, in order to solve this, let's just separate your function here into two components. We can separate this into two components. The first one is 0.2s over s square plus 1.96. The other one is 1.4 over s square plus 1.96. Now, if you were to refer back to the table of Laplace transform, you realize there is a pair when you have, like for example, when you have s over s square plus omega square. Okay, this is for fs. When you have this for your in spatial domain, the pair of it in time domain is actually this is cos omega t, yeah. So this is one pair of function in spatial domain and time domain, meaning that given this input in time domain, you will get this input in spatial domain via Laplace transform, and the inverse of Laplace transform is the opposite way. Now, the next pair is you have fs is equivalent to omega over s square plus omega square. Okay, when you have this function in spatial domain, you have another function in time domain, which is sine omega t. So this is another pair, which indicates that when you have this function in time domain, when you do Laplace transform, you will get this function in spatial domain, and the inverse transform, you will get the original signal in time domain. Okay, we are done with that. So let's go back to our original function. Okay, so in order to do this, we need to convert this 1.96 into omega square. Okay, you have another 1.96 here into omega square. So what is omega here? You realize that 1.96 is actually 1.4 square. So your omega here is actually 1.4. Okay, so let's just substitute this into our equation. Okay, so we replace that with 0.2s over s square plus 1.4 square, and the other one is 1.4 over s square plus 1.4 square. Right. So now let's try to get the inverse Laplace transform of this. So we can do inverse Laplace transform for individual components, since this is a positive or plus operation. So this is equivalent to inverse Laplace of 0.2s over s square plus 1.4 square, right? So you can add with another inverse Laplace function, which is 1.4 over s square plus 1.4 square. All right. So the result for this will be 0.2. The first one is s on top, which is, if I may highlight here, yeah, this is actually because we have s here. This is similar to the first pair, all right, and this one without an s is similar to the second pair. So the answer is 0.2 cos omega t. So your omega is 1.4, so it will be 1.4 t, plus the next one is just sine, sine 1.4 t. You may wonder, where do we get 0.2 here? This 0.2 comes from we treat it as a constant from this part. All right, so that's how we get 0.2 cos 1.4 t. So that's it. This is a basic, very simple example of inverse Laplace transform. That will be it for this video. Thank you.